Today I need to show you how we can represent this proportional relationship that we've been looking at and figuring out the rate of change, our rock, and showing you how we can actually make that into an equation. Now, the first thing you need to know is that the rate of change has a new nickname, K. And I was having a really tough time trying to explain why it's K and trying to give you a way to memorize that when suddenly a brilliant student raised their hand and I thought, well, gee, I'm trying to make a point here, make it fast, but I thought better of it. And I said, yes, sir. What do you have to say? And he said, I know why the rate of change can also be known as K. And I said, okay, fine. What is it? And he said, well, because it's rock. And you know that we're used to saying that the rate of change is rock. Well, rock ends with K. And suddenly I went, you know what? You're absolutely right. I can use that as a memory tool. So the rate of change, we know it as rock, and you spell rock R-O-C-K, and we were using the R-O-C to stand for the rate of change. Well, the nickname for the rock is K. The nickname for rate of change is K. So it makes this a lot easier. How do you build an equation? Well, we're going to use y equals the rate of change times x. So our rate of change is right there is the K, and that stands for the rock, the rate of change. And so one letter represents the whole rock, the rate of change. And when you write this equation, the y is going to be there and the x is going to be there, okay? So you don't have to think about, well, gee, what's this letter have to be and what's that letter have to be? It's always going to be y equals whatever that rate of change number is and x. So the y and x will always be in there. So if my rate of change, if my rock, and let's just go ahead and put in that k right there. If my rock was 3, see where that k is right there in front of the x? Well, if my rock was 3, that would make that y equals 3x. That's the equation, and it's that simple. So let's go down and take a look at a few others. If the rock was -2, how would I build the equation? Well, it'd be y equals, then I would put in my rock of -2 and put the x right behind it. Now, what does this mean? How can I actually use this equation? Okay, fair question. Well, let's go back to if our equation was y equals 3x, where our rock was 3, okay? Well, what if they gave you the equation, okay? So y equals 3x, and they gave you a table that was like halfway completed. They gave you the x's, but they did not give you the y's. Well, if you know the equation, and you know that this equation goes with this table, you take this x value of 0, and you stuff it in right there for that x. So it's 3, 0. Now that does not mean that you write in 30. No, 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 no. What it's trying to show you is that the 3 is going to be timesing x. See that 3 is timesing x, so it's 3 times 0. What's 3 times 0? 0. And then what you do is you move on down to the next x. Well, the next x that they gave you was 1. So instead of putting in a 0, you'd put in a 1. And 3 times 1 is 3. And then you move on down to the next x. Well, instead of putting in a 1, you'd put in a 2. And it'd be 3 times 2, so your y value would be 6. Now what does this mean? If I take these points right here, see this is an xy, that'd be 0, 0. So on a graph, it'd be 0, 0. I put my red dot right there representing 0, 0. The next one I would graph would be 1, 3. So I come over to the 1 axis on x and then up to the 3 and put a dot up to the 3 on the y axis. So 1, 3 is graphed right here. And then the last one would be 2, 6. I come over 2 to the x-axis, I go up 6 to the y-axis, and I put a dot. These 3 points are on a straight line, and it's through the origin. So I know that this table is proportional. So how does this equation fit into the stuff that you know about the graphs and the tables? Well, now you can complete the tables, and you can also answer weird questions too. It can predict stuff like, Well, can you predict what y will be if x is 30? That means if x was 30, what would the y be? Well, 30 would be our x value, so we'd plug in 30. 3 times 30 is 90. And so that's how we use this equation right there. And it's very easy to build. We just put our rate of change, our rock, right in front of the x. Also, please remember anytime that you see y equals kx, well, that just stands for rock. Why does it stand for rock? Because rock ends with a k.